Good afternoon, everyone. Can you hear me at the back? Yeah. Okay. So thanks for having me here. I'm going to be talking on something rather conventional called SQL injection. I'm pretty sure everybody over here understands the problem. It is something which has existed for over 20 years. I mean, ever since there were any web applications, there was something called SQL injection, and this is a problem which is probably will stay for another 20 years. A little bit about myself. Okay, before I start, I've made a few changes. So what I'll try to do over here is something a little bit ambitious. I'll try to do some live demos. So I've got a box at home set up with all these vulnerabilities, and I'll try to exploit it while I'm here. So I don't guarantee that everything will work, but we'll see what works and what does not work. So a little bit about me. I work as a senior security something at a company called 7Safe in UK. I've been doing this for more than 4 years now, penetration testing. I've spoken at a few conferences, and this is my blog, notsosecure.com. It actually might be not so secure, so don't try to hack it. But I post some stuff over here, mostly related to web applications because that's my area, and generally focusing on SQL injections. So I've got lots of slides. Well, I hoped I would have lots of slides. I was planning to write these up last night, and then I woke up this morning thinking I should have had one less beer. So anyways, the demos hopefully should work, and that they should make up for the slides. What's the agenda for today? The agenda for today is broadly on exploiting SQL injections. I'll be focusing mainly on two databases, MS-SQL and Oracle. A quick show of hands, how many people over here actually work with Oracle, like DBAs or developers? Anybody? That's good then. Then I can just talk any crap and just get away with it. Okay, there's one over there. Anyways, so I'll be broadly covering two things. I'll be covering privilege escalation. So you find a SQL injection, and then you find that the connection string is not very privileged. So you are executing some SQL with certain user levels, and that user level is not sufficient. So you do some privilege escalations. And broadly, I will be covering OS code execution. So you found a SQL injection. How can you then run OS code execution? What I will not cover is, I would have loved to cover this, but I don't think I'll get the time, is data extraction. There have been quite a few recent advancements, like extracting data over DNS. This is something called as out-of-band channels. So you find a SQL injection. You could typically exploit it using blind channels, but I would recommend reading the slides from DEF CON 15. A guy called Patrick, he did a very good demo on out-of-band channels. And lastly, I will not cover any of MySQL. MySQL. For this, I would recommend reading Bernardo's slides, which he presented in Black Hat Amsterdam this year. Okay, so let's get started. So what is SQL injection? I don't think it needs any introduction. Basically, it's a vulnerability in which developers use unsanitized users' input in SQL calls. And then what can you do if there's an SQL injection vulnerability? So as an attacker, you could compromise confidentiality, integrity, and availability, which is typically referred as CIA. So when we say breach in confidentiality, what we mean, say if your database store credit card data, then you could return those credit card information. That's breach in confidentiality. We'll see execution of system code, which would mean that attacker now has an access onto your DMZ network maybe, and he can attack maybe your internal components, which you think would be secure because they are not exposed over the internet. Data can be altered, so update database statements and things like that. Data can be destroyed. Typical example, drop database, drop table. So this is a typical example of a SQL injection, which some people refer as OR1 is equal to 1 attack. All you do over here is the injection point is in the where clause. So you inject something like username is equal to a single tick or 1 equal to 1. So the second part of the query, or 1 equal to 1, is always true, and it returns some records from the original query. And then you do something like hyphen hyphen, which is a comment in the SQL server, and you comment out the rest of the code or the logic behind it. This is a very trivial example of SQL injections and bypassing authentication. It probably does not exist anymore because all these instances have already been compromised by somebody, and they must have learned their lessons. Okay, so let's get our hands dirty. Let's go back to the days of 1990s when this thing called SP_CMD shell rose to the occasion. This was a stored procedure. This was a stored procedure in MS-SQL. So it's MS-SQL 2000 and 2005. But let's start with MS-SQL 2000. So it was a stored procedure which was available at SQL Server. Typically, the stored procedure will only be available to the users in the role sysadmin. So if you find a SQL injection with SA privileges or sysadmin privileges, then you will have access to this XP_CMD shell procedure. And this stored procedure will just let you allow OS code on the remote box, and you compromise the remote database host. I mean, simple as it is. Now, the trouble is, so if you execute the OS code using XP_CMD shell, then under most of the cases, you would want a complete interactive shell. So, I mean, the old school way to do this is because it's a Windows box, it's a SQL server, it will have a TFTP client. The TFTP client is installed typically on all Windows installation. So you run a TFTP server. That TFTP server will serve a netcat binary. Using your XP_CMD shell, you make the Windows the database host connect to your TFTP server, make it download a netcat.exe. Once it has the netcat.exe, just run it and get a reverse shell. Okay, so simple as it is. Now, there are a few modern day tools out there now. One such good tool is SQL Ninja, which does not rely on a TFTP server because for this to work, first of all, you need a TFTP client on that box, which generally is available, but in some cases, maybe it is not available. The second, the most important drawback of this is that the database server needs to reach out on your public IP. So it needs to have the outbound internet connection, outbound connection on your TFTP port, which will be disabled. So this TFTP approach is not very foolproof, and it might not work in cases. So SQL Ninja actually uploads this netcat.exe onto that box using an approach simple as copying netcat.exe binary as hex into a temporary table in the database, and then copying that table out onto a local file. So it doesn't actually need any outbound connections. You can just do a bit-by-bit copy of the file and have that file on the box. Okay, I'll do the demo of this a little bit later because I want to go through the next slide because I will be doing a demo in SQL Server 2005. So SQL Server 2000 was quite trivial. You find a SQL injection. Okay, I missed something. Oh yeah, sorry. The main point, open row set. Okay, so SQL Server 2000, if you find a connection, if you find the SQL injection with the user SA or an equivalent privileges, and you have access to XP_CMD shell, it's plain and simple, it's game over, because the code which you run, which will be run as with the privileges of system user, that's the user which runs the SQL Server process. So if you find SQL injection with SA privileges, plain and simple, it's game over. But what if your injection point is not with the privileges of SA user? So I've got a demo over here. So this is a simple SQL injection challenge I wrote, or rather somebody else wrote. So if I put a single tick in it, you'll see it just returns a SQL error indicating it's a SQL injection here. Now, this is over here, the error messages are enabled, but and the the input actually goes into an integer field, so I don't need to close any single ticks or escape anything. So if I do a simple query, system underscore user, and see what user privileges I'm currently running my SQL as, then you will see that this one particularly it says I'm running my SQL as user SA, which is a privileged user, and over here exploitation is simple. I was supposed to be showing you default 2.asp, which actually does not have SA privileges. So if I do the same thing over here, then you see this is running with a username called testing, and this user is actually a very unprivileged user. It doesn't have access to xp-cmd shell. So if I try to execute xp_cmd shell here, so let's say if I do exec master.xp_cmd shell and then ping google.com. So if this works, it should really have some time delay because this process to exit ping will take at least like 3 seconds. But you see in this case, it doesn't work because simply for the reason that my user testing does not have access to xp-cmd shell, so that failed. So SQL Server 2000 allows a functionality called open row set. So open row set is a feature basically if you are a developer and you are working on a current database, then open row set allows you to make a connection to a remote database, fire a query on the remote database, and whatever is the output of that query on the remote database, process that output in your current database. So all you do in open row set is provide it an IP address, provide it a username and a password, and it will establish a connection to that database and then run your query. So over here, if you see the syntax for open row set, the first part is the SQL OLEDB, which is the drivers. That's a constant thing. The second part, which is null in my case, is this part over here. This is where the IP address goes. The third part is the username. The fourth part is the password. And the next part is the query which you want to execute on the remote box. So this open row set feature, what you can do is then make it connect not to a remote database, but to itself. And in a process, provide it a username and a password. So what you're doing over here is essentially brute forcing or guessing a password for a privileged account. And if this works, then you can actually run the xp_cmd shell on the same box with the privileges that you have just cracked. So let's just go back to our demo. I actually have a cheat sheet here to help myself in case I get struck. Okay, so in our injection, let's try to use the open row set again, and let's try to guess the SA password of the remote box. And if we successfully guess the SA password for the SQL server on this box, then we will be able to run queries with the SA privileges. So let's say let's try the username SA and let's try the password test. And if this connection is successful, then it will run a query which is basically select one, wait for delay 30 seconds. So essentially, if it's a completely blind injection and I have to brute force it, then the only way to find out if my username and password is correct is if the password is correct, then the query wait for delay 30 seconds will get executed and my database server will actually wait for 30 seconds. So let's try this out. Let's see what happens. You will find that in this case, the error messages are actually enabled on that box. So if our password is not correct, it will tell us that the authentication failed for user SA. But this attack scenario is actually valid even when the database error messages are not enabled. So you can actually see whether the SQL responded in 30 seconds or not and make out even if it's a blind injection. So if I fire this in, then you see this did not wait for 30 seconds. And in this particular case, the error messages were enabled, and it has told me that login failed for user SA. So that's fine, it failed, but now I know that the password did not work. So let's try some other passwords. Okay, before I try this, could somebody give me some default passwords for SA account, what we have seen in past? blank, yeah. SA password SA. Okay, but in this case, actually, the password which I kept was a really secure one, test123. So you will see that it actually is waiting for, I haven't actually received any response, and the SQL server is going to wait for 30 seconds. So I have successfully cracked the SA password. Now, this attack, Chris Anley from NGS Software originally came up with this attack, and he wrote a very nice paper. And then SQL Ninja implemented this attack. And I mean, if you are into brute forcing, then this attack actually allows you to use the resources of the remote database. So you can use the computation power of the remote database to brute force it. So anyways, nothing failed here. So now we've successfully cracked the password for the SA user. So once we've cracked the password for SA user, now we shall be able to run XP_CMD shell. No problems. So let's do that. So I'm gonna run XP_CMD shell and make it throw a reverse shell back to some other IP address. Now I'm gonna skip that phase of making it connect to a TFTP server and then uploading a netcat.exe. Okay, for this demonstration, let's assume that you have done it somehow, and a netcat.exe is present on the remote box. It will not be in the real case, I mean, unless it has already been compromised, in which case you are investigating it too late. So what we are going to do over here is that we're going to first escalate our privileges from the user testing to that of the user SA, and then after it has successfully connected with the SA privileges, then it will execute XP_CMD shell. In this particular case, the binary netcat.exe is already present on that remote database. It will not be in scenarios. So I've got an IP over here. I put a box over here. Let's copy this IP address. So I'm going to make a netcat listener listen here. Okay. So if I fire this in, then you will see that we first escalated our privileges from testing user to the SA privileges, and then from SA privileges, once we have access to XP_CMD shell, then we made it throw a reverse shell back to us. So at this point in time, the attacker has access to the remote database. This is the shell from our Windows box. So if I do an ipconfig and stuff like this, then I basically just owned the remote database. Okay, so this is where things start to get interesting. Now, things changed under SQL Server 2005. This box I was showing, I was basically making it act like a 2000 box. This was actually a 2005 box. And under 2005 box, the SQL Server service agent does not run as system. It runs as network service. And this user network service is actually a limited user. So you will see in this particular case, the shell which I've got, if I do who am I, you can see it all right, yeah, at the back? Okay, so if I do a who am I, then I'll find that under 2005, SQL Server 2005, I'm not really system, I'm network service. So what the hell does that mean? That means that I am actually quite restricted. So if I try to do, doesn't quite work. So access is denied. Hello. Okay, so I mean, all that hard work was at a waste. So you can still do stuff, like you can read some certain files on the box. You can issue some commands like ipconfig and have a look around. You still have now a route to the internal network, but this is not really as useful as it was in 2000 because the agent itself is running as network service. Now, remember this vulnerability in Windows called token kidnapping? Anybody? MS-09, I actually have that number here somewhere. Okay, MS-09012, yeah, that one. So it was basically a privilege escalation in Windows, which you can use to then escalate your privileges from network service to that of system. I don't frankly understand that vulnerability very well, but all it is in terms of the person who found it, is if you can run code as network service, you can run code as system. This was, by the way, fixed by Microsoft. It remained a 0-day for like 3-4 months, and then it was fixed by Microsoft in earlier this year. It was fixed by MS-09012. So anyways, this box is still vulnerable, and it has the exploit. Again, you have to transfer your exploit onto this box, but for the purpose of demonstration, let's just assume this exploit is already there. So the exploit is fairly simple. The exploit basically just says command to run, and it will run it as system. So if I just do so if I do a command who am I, then you see it says I'm basically system. So if I now do it says command successfully completed, and now if I check the users on the box, there is a user on the box called sect. So there are two privilege escalations here. First of all, with the open row set, we've escalated the privileges of the user in the connection string, and then secondly, after we've gained an interactive shell, we found it was limited to the network service only, and then we used a Windows privilege escalation from which we escalated our network service to that of system. And at this point in time, you've completely owned this box. You are system on this box, and you could do stuff like hash dump, pass the hash, use the pass the hash toolkit once you have the hashes, and the fun part starts from there. Anyways, so if there are any questions, feel free to ask them now. Any questions at this stage, or shall I proceed? Okay, fair enough. Under 2005, XP_CMD shell is disabled by default, but if you have SA privileges, you can enable it. So it's just one line of code which you say SP_configure, and then there is some parameter which takes and just enables XP_CMD shell. But the trouble is that you can only enable it if you have the privileges, which is typically the SA or sysadmin role privileges. The other problem with 2005 is that open row set is not available by default. So so if you find a SQL injection and your connection string does not have a privileged user, then you are really stuck with the privileges of the current user. There is not much you can do. So let's look at a few scenarios where you can do stuff even with your connection string being a less privileged user. Now, sometimes when local administrators or when system administrators configure the SQL Server service agent, they configure it to run with the privileges of a local or domain administrators. So that process does not run with the privileges of system or network service. It runs with the privileges of domain/local administrator. Now, what I mean by that is, if you actually go to, I actually have a SQL Server installed, so I can show it quite quickly. So yeah, this process over here, I've got a SQL Server Express edition here. Yeah, so sometimes the system administrators, they actually configure this agent with certain accounts. So instead of having network service over here, they will have a local administrator or a domain administrator account. Now in those cases, what can you do is, you can make this SQL Server connect to your SMB share, right? Make this SQL Server follow the NTLM challenge response, the way SMB authentication works. So send it a pre-calculated NTLM challenge, and whatever response it sends, you can then brute force the, hello? Okay, let me just turn this off. Yeah, so you can send, you can do that NTLM challenge response. Whatever response you get, you can then try to crack the password based on that. I have a video for this. Before I do this, sorry about this, guys. Okay. Before I do this, this is basically a known issues with Windows. This is something which has existed ever since Windows came into existence. It's basically if you are logged into to your Windows account and you try to connect to a Windows share, then Windows will think that you have an account on that box as well, and it will try to authenticate with your current login credentials, and in the process send out your current. It will basically try to respond to the NTLM challenge with your current password, and this is the vulnerability. Okay, so I have a video for this. Okay, so it's the same SQL injection. At the moment, I mean, I can't do it over here because I need more than one machines for this to happen. I need somebody who can send challenge and somebody who could respond to it. But it's the same SQL injection. So what I'm doing in this video is first showing it's a SQL injection. Let me just skip this phase. And then I'll show the version, and it says SQL Server 2005. And then I show what the current user is, and the current user would be with the privileges of a test user. And then I start a notepad and start writing that SQL Server 2005, your connection string is not privileged, so you can't do much. Open row set is not available. Then for this to work, the SQL Server agent must be configured to run as some user account and not under a network service or system. So then in the attacker's box, I have a Kane running over here, which I have configured to do this NTLM sniffing. So I run this Kane, and then under the SQL injection, I fire a stored procedure called XP_dir tree. Now this procedure is available to all users, not just the SA privileges user. Any user can call it. So my current user has the privileges to call it, and I make it connect to //192.168.5.135. This is where I'm running Kane. So if I make it connect to Kane now, you will see that it will do some challenge response. And in the Kane, I have got the NTLM challenge response handshake now, and I can see that the connection from the remote database to my server was as a user called administrator. The authentication failed because, of course, it was a fake challenge which I sent to it. Now I can run through a dictionary attack because the challenge which I sent was a pre-calculated one. So if I then give it a dictionary file, then you will see the password it has already cracked is ABC123. So although you are restricted with the same user, there might still be certain attack vectors which you can use. This was one of them. Now, remember the Windows SMB reflection attacks? Anybody here familiar with Windows SMB reflection attacks, in which you basically do a man in the middle, right? You get a challenge, and then you pass the challenge on. You then get a response, and then you pass the response on. So you don't need to crack this hash essentially in the reflection attack. You can use the same hash itself to log into a remote database, to log into a remote Windows host. So you can still use that, but the trouble is it was fixed by MS-08068, so the reflection attack does not work after MS-08068, but you can still crack the hash. Okay, so we're done with MS-SQL. Any questions here before I go on to Oracle? Okay, so this Oracle is something which I've only just started playing. I'm not an Oracle geek by any. I don't claim to be an Oracle geek. I've only just started playing with it, and I found it really interesting. So, but what I found was people have talked about hacking Oracle, and people have been talking about it since last 10 years maybe. I mean, the likes of David Litchfield, Alexander Kornburst, they have basically ripped Oracle apart. I mean, and so much so that they are now actually bored about it, bored of hacking Oracle. They don't hack it anymore. Okay, but the trouble is, most of the talks or most of the papers, or even the Oracle Hacker's Handbook, it talks about hacking Oracle database from the network level. So, so you get access to the TNS listener port, and then there are a number of ways to hack it. For example, the common attack, Scott Tiger, username, password. You enter into the database, and then you run some exploit and become DBA. Or typically, remember the Raptor exploits? Anybody? So you could write files in the rhost files and stuff. So, okay, anyways, the agenda is how do we take hacking Oracle from web applications? Because typically those TNS listener exploits and stuff will only work on the internal network. So I'll be talking about hacking Oracle from web. That includes SQL injection, hacking Oracle application servers, SQL injection, OS code execution, and I'll show some SQL injection worm. So some housekeeping stuff. First up, Oracle comes with a lot of stored procedures and functions. Now, when I say a lot, I know, I mean, these are definitely hundreds, if not thousands, and which is fine. But the trouble is that people have found an n number of vulnerabilities in these default stored procedures. Now, why is that bad? This is bad because these functions and stored procedures, they by default run by the privileges of the definer and not the invoker. So an easy way to understand is think of SUID files, binaries like passwd binaries. So they run with the privileges of root, even though you execute it. So similarly, these functions and stored procedures, they execute with the privileges of the definer. And in most cases, this definer is a very high privileged user, like sys, which typically, I mean, DBA is like root on Linux. So if you get DBA, you basically own the database. So if you have to write a function or a stored procedure and make it not SUID, I mean, as an example, then you have to explicitly specify this keyword called authid current_user, and this will mean that the stored procedure or function will now run with the privileges of the invoker and not that of the definer. So in a nutshell, if you find a SQL injection or a SQL injection, I'll differentiate these two in the next slide. So if you find a SQL injection in a function or a procedure which is owned by a high privileged user, and it runs as a high privileged user, then whatever you inject, that SQL or SQL, that runs as that high privileged user. So a vulnerability in these functions or stored procedures basically imply a privilege escalation. Okay, now when we talk about Oracle SQL injections, there are typically two categories. There is a SQL injection, or there could be an SQL injection. Now, SQL. Now, okay, as I said, I've only just started playing with Oracle. So my vague definition of SQL is, think of it like a freely floating chunk of code, which is wrapped between begin and end clause. So anything which goes between begin and end clause, and it's got a structure of a SQL, that's a SQL. Unless somebody else has a better definition. I'm pretty sure there is a better definition. But anyways, so a SQL is basically you have a begin and end clause, and then you write some SQL wrapped between these two, begin and end. Or you can have a SQL, which is a simple single SQL query like select star from table name. So what I mean by SQL injection is, it's an injection in an anonymous SQL block. If you find an injection in an anonymous SQL block, then the attack has no restrictions. You could execute DML and DDL statements, You can terminate the original query, use a semicolon, and then start a new query, just like an MS-SQL server. However, if your injection point is in a single SQL statement, like a select query, then you have certain restrictions. Oracle, in those cases, do not support the use of semicolon by design, so you cannot stop the original query. If your injection is in the select query, then you have to do everything in that select query. You just can't terminate the select query and start an insert or a drop database clause. So anyways, in a nutshell, PL/SQL injection is easy to exploit from an attacker's perspective. A SQL injection is slightly difficult to exploit. So a typical example of PL/SQL injection is over here. So what I've done over here is I've created a sample procedure called orasaso.test. Now, orasaso is one of the default packages which you get after you install Oracle application servers. So anyways, you can ignore that part for the moment. So it's a procedure. It takes a parameter called q, and that parameter q is then concatenated with the string begin and end. And so it basically then creates an anonymous PL/SQL block, and that anonymous PL/SQL block then gets dynamically executed with execute immediate. I mean, if you guys are from MS-SQL background, then an easy way to think of it is like it is a prepared statement, but the statement which is getting prepared, you can actually control that part. So it basically asks you to provide a statement, and then it will use the prepared statement and run it. So this is what is happening over here. So if you find these scenarios, then the attack is actually very trivial. So a typical example would be just this. So you can provide the value of q is equal to null, and then execute immediate, grant DBA to public, end. So this will basically just grant the DBA role to public. So any database user now is now a DBA user. Okay, so I'm going to show a little example of where will you find PL/SQL injection. Typically, you will find PL/SQL injections in Oracle Application Server. Now, well, I think this slide I should have probably I should have presented this slide like 10 years ago. But anyways, Oracle Application Server has had a series of vulnerabilities. This one is a classic vulnerability. This one was, okay, let me give a little bit of background about Oracle Application Servers. It's a special URL. It's a URL which is special to the Oracle Application Server. It has these parts. So the first part is the host name or the IP address. Second part is the port number. The third part is the /pls, is the start of the PL/SQL gateway. So there is the PL/SQL gateway which connects to the remote database, and then there is an application server. So this PL/SQL gateway, when it connects to the remote database server, it needs to know the database server's IP address. It needs to know the connection string, like username and password. So these things are saved in something called as a database access descriptor file, or in short, DAD file. So this part after /pls, which you see, is typically referred as DAD, database access descriptor. So it tells the PL/SQL gateway that you should connect to the remote database with this user. Second part, orasaso.home, it again has two parts. The first part, orasaso, is the name of the package. So orasaso stands for Oracle Single Sign-On, and home is the actual procedure which we are calling here. So this had a PL/SQL injection vulnerability. So you can inject your PL/SQL, and that will get executed. Now the trouble is, it will get executed, but it will be executed with the privileges of the current DAD user, which in this case happens to be OraSSO, or Oracle Single Sign-On user. And this user is actually this is a least privileged user. It does not even have the privileges to create a function. So, how do we go on exploiting it? So what we then do is, because we can execute PL/SQL, then we can call the vulnerable packages in the backend database and exploit these packages and then elevate our privileges. Right. So this really needs that the backend database has some vulnerable packages, and the backend database, I mean, even in today's today, I mean, there are so many vulnerabilities in the Oracle backend database, and Oracle is still trying to fix them. So I wrote something called as OAP hacker. It's a simple Perl script which exploits a SQL injection vulnerability. So if you have found a SQL injection vulnerability, then it will launch a series of exploits based on what backend database, based on what Oracle backend database you're using. And once it's successful, then it will give you the DBA privileges. So, okay, first thing, it launches exploits on the backend database. If successful, it gives you the DBA privileges. If successful, then it builds up a Java function which will let you execute OS code. As simple as that. So this is how an Oracle application server looks like. This is 10G second release, I think. So based on that vulnerability I showed you, we can use a procedure called OVA_util, a package called OVA_util, and make it print stuff. Okay. All right now? Yeah. So I've run a query here saying select user from dual, and it tells me my current username is orasaso_public. And as I mentioned, it's a very less privileged user. So if I do a select star from sys.user$, this is the table which contains the Oracle password hashes, then you'll see that this attack fails. This is actually Google's 404 page, but it's a 404 return from the server. So this attack has failed because my current user, orasaso_public, do not have the privileges to read this table, sys.user$. So I wrote a Perl script called OAP hacker, and it exploits this SQL injection vulnerabilities. All it does is basically it asks you to do is provide it a URL which is vulnerable, and then the OS command which you want to run. So this is the one which is vulnerable, and if you want to run the command ipconfig, then it will first check our privileges. It will first check if our backend system is vulnerable. If it's vulnerable, then it will first check our privileges. If we are not already DBA, it will launch a series of exploits and make us DBA, and then it will build up this Java function for OS code execution. And then it will essentially give you a URL by which you can just directly run OS code. Okay, so let's just hit it go. So it says we are not DBA over here. It first checks for the URL. It says the URL is vulnerable, proceeding to step 2. It says we are not DBA right now. So it then launches a series of exploits. At the moment, it has got 6 exploits. And depending on what version you are running, it will exploit the backend. So it has sent the first exploit, but sometimes there are some caching problems. So anyways, the exploit succeeded here. And then says we are DBA now. So after it gets the DBA privileges, then it builds up this OS code execution module. So it then builds up a Java library, and then grants permission to Java, and then finally builds up a Java function by which you can execute OS command. And it then gives you a nice URL by which you can execute OS command. Okay, before we do this, now because we have our DBA privileges now, so this URL which failed earlier when we were trying to select the password hashes from sys.user$, this should work now because we have DBA privileges. And if we refresh this, then you will see these are all the password hashes from the sys.user$ table. For example, This thing over here is a hash for the user portal underscore demo. Anyways, so if I just copy this URL now, there you go. So this is the output for the command ipconfig. And now you can just, basically you have a shell over HTTP. So all you need to do is just type your command over here and it will give you the output just like you were using a normal web shell. So that's sent. Now you are running code as Windows, Oracle in Windows runs as system. So you are running OS code as system. This is fairly generic. So if you find any oracles installed on Linux or Solaris, you can still execute OS code, but you will be running OS code with the privileges of the process running Oracle. It will typically be an Oracle user. Okay. Do you have any questions at this stage, or shall I proceed? Okay. Yeah, so over here in my Perl script, I've used this thing called cursor injection. So even though our user was not privileged enough to create any own function, any own dodgy functions, it does not need those functions because there is something called as cursor injection where you compile a query and put a cursor and then you basically inject this cursor into the vulnerable procedure. Anyways, so using this, it can still work around that create function privileges. Okay, so now let's talk about something which you will probably find out there in the wild and which is probably more common than PL/SQL injection. It's SQL injections in with Oracle backend database. Now a common conception of exploiting SQL injection in Oracle backend database is that it does not have XPCMD shell. So how do I execute OS code? Or it does not even support the execution of multiple queries. So how do I go about doing things like executing OS code? That's what we will be talking about here. So the first assumption that it does not support nested queries is right. This is our design. So if you have an injection over here in a query, select A from B where C is equal to your input. Now in this case, you are limited to the select query. You can't just have a semicolon here and start a new query, insert or update. Oracle just does not support it. So in order to execute multiple queries, we really need to find an attack vector by which we can execute PL/SQL. Because if we have to execute OS code or do something nasty, then we need to run multiple queries. We just can't do everything in a select query. So an easy way to do it is if there is a function, okay, because in SQL queries like select queries or insert queries, what you can do is you can call functions. You cannot call procedures because for calling procedures you need to end the query and then start a new statement called beginning with exec or execute immediate. But what you can do is you can call functions. So in the same query, I can call a function, and if that function is vulnerable, then I can use that vulnerability within that function and do stuff. So a typical example is if there is a function which is vulnerable to PL/SQL injection, then I can call that function in my SQL, my select query, pass my PL/SQL as an argument to that function, and thereby indirectly execute my PL/SQL with this function. Does that make sense? It will probably become clear when I show you an example. Okay, this is not the only case. This was presented way back in 2005 at Black Hat. So if you find a function which is vulnerable to buffer overflow, it's end of story. I mean, what privileges, what Scott, what Tiger, it's just buffer overflow. You just execute code with the privileges of the process. So it's end of game. So this function was vulnerable to buffer overflow. and you could just execute code like that. So output of dir goes to that file. Okay, remember I mentioned about the privileges with which the function gets executed. Now, when we call this function in our SQL, there can be two cases. This function might have the auth ID of current user, or this function might have the auth ID of definer. Okay, the first case, if this function has the auth ID of definer, and it's defined by a high privileged user like sys, then you don't have to worry about your privileges, because whatever you are injecting, it's being called by a function which is running as a high privileged user. So you're directly executing your PL/SQL with the privileges of sys user. That was the first case. Second case, if that function is not defined by a high privileged user, or is defined by a high privileged user but has auth ID current underscore user, then you can execute PL/SQL, but your PL/SQL will be executed with your current privileges. So it's not a direct privilege escalation. But what you can do then is, because it allows you to execute PL/SQL, then you can again call any vulnerable package in the backend database and exploit that. Right, it's getting a little bit confusing, I think, right now. So anyways, when I give you a demo, this will clarify a little bit more. The takeaway from here is that if a function is vulnerable to PL/SQL injection, it's simply game over, right? You can execute OS code irrespective of what definer privileges it is, if it's irrespective of whether it's auth ID definer or whether it's auth ID current underscore user. If it's definer, it's definitely game over. If it's current underscore user, it then depends on what sort of patches have been installed on the backend databases and stuff like that. So there's a very popular package in Oracle called DBMS export extension. It's really popular among security researchers because it has had a series of vulnerabilities in the past. In particular, I'll be talking about this function called get domain index tables. So this function was vulnerable to PL/SQL injection. This was owned by sys, and so you can basically just call this function in your SQL query, inject your PL/SQL, and that PL/SQL will basically run as sys. So you are not restricted to select queries. If you find a SQL injection in select, you can do insert and update statements, and as we will see, you can execute OS code as well. So this is what the function was doing. It was taking this type underscore schema and type underscore name as an input variables, and those two parameters were then used in the creation of PL/SQL, anonymous PL/SQL block, which was then getting executed. So again, think of it like it is executing a prepared statement, but what the statement is basically controlled by you, right? So this was the exploit. This was again released by David Litchfield. This is actually an old vulnerability. This was fixed by Oracle in 2006. But because of the way Oracle patching works, you will actually find this quite a lot in the wild. I personally, while doing proper pen test for clients, have found this vulnerability still present in the client's database. Now, why is it that it is still present? It's because the way Oracle patching works. First of all, you pay for the software itself to the Oracle, and then if there's a security vulnerability, then you have to pay for the patches as well. So it's not like you got a product and you get patches for free like Microsoft. Oracle doesn't work like this. So you need to pay for the patches. And secondly, even if you pay for the patches, Oracle patch deployment requires a downtime. So a typical Oracle customer will have 1,000 instances of Oracle. So imagine a couple of hours downtime on all 1,000 instances. That's a lot of downtime. And customers sometimes cannot afford to have such a long downtime. So they just ignore the patches. And it is actually quite common to find Oracle database which have never had patches applied. So I wrote a simple tool called BSQL-BF. It's a framework for blind SQL injection. I hate discussing about this tool because there are n number of tools out there. There are some very good ones, SQL map, and this tool does not stand a chance in front of those tools. And I highly recommend running the better tools than this one, but it has got some features which the other tools do not have in the current stage, and maybe you want to run this tool for these features. So I'll only describe these features. So this is how the tools looks like. It basically is a framework, as I said, for exploiting blind SQL injection, and so you tell it that this is the true response, and based on that, it will extract data from the backend database. It supports MS-SQL. Where is it? Yeah. So it supports MS-SQL, MySQL, Postgres, and Oracle. It basically, I wrote this for extracting data from backend databases. Now, the feature which is quite cool here is this Oracle exploitation. So you can use this to run OS code on the remote Oracle box. Let's start with an Oracle challenge. Okay, so I have Oracle SQL injection over here. So the vulnerable part is the parameter called name. So if I do name is equal to 11, name is equal to 10, then it returns something from the backend database called accounting. So if I do 11 minus 1, it still returns accounting. If I do just 11, it does not return anything. So, and if I do 12 minus 1, sorry, 12 minus 2, it still returns accounting. So basically, whatever my input is, it's going into the where clause, and these arithmetic operations are getting performed in the where clause. So it's a simple select query, select some item from some table where this parameter is equal to, in this case, it's 12 minus 2, which is 10, and hence the result. So using this blind SQL injection technique, now you can exploit it. So you can say, so you first provided a URL, then you provided a database type. In this case, it's Oracle. Now, modern day tools like SQL Map, they actually fingerprint the remote database for you. Mine is a little dumb, so you need to tell it what you want to exploit. So in this case, you're exploiting the Oracle database, which is type 3 in this case. And then you give it the SQL query which you want to execute on the remote box. So in this case, I want to do select user from dual, which will return the current username for my SQL injection. Okay, and then what you need to do is provide it a matching string, which it should identify in case of a true and a false response. So every time my query is true, it will return this string accounting, and every time it's false, it will not return this. So this is the deterministic factor. So if I run this, then it has found the length of my SQL query, and it will, based on this blind SQL injection, because you don't extract data based on the error messages, it will tell you that this connection is actually with the privileges of Scott user. Now you must be aware the Scott user is one of the low privileged default accounts in Oracle. It is not a DBA user by default. Okay, before we do this, our user actually might be DBA because we ran an exploit on the Oracle application server, and we gave everybody DBA access then. And I haven't, quoted the OAP cleaner to clean that exploit later. So this user will have the DBA privileges. So let's just revoke our DBA privileges first. You remember this exploit. So everybody was DBA then, and hence we could select the password hashes. So we need to revoke it. So now it has been revoked. So now I don't have privileges anymore. So, okay, let's go back to our exploit. So using this blind SQL injection exploit, so let's select something. So what we are trying to extract now is the password hashes from the sys.user dollar table and see if it works. Now this will fail because our user does not have the privileges. Let's see what happens. So it has not found the length and it says error, something is not quite right here. So the exploit failed. Basically, you want to get rid of me already? Okay, just 10 more minutes, yeah? Okay, so the exploit failed because our user does not have the privileges. So it now supports this DBMS export extension exploit, which is a type 3. So if we run this, then it will first run this exploit, give us a DBA privileges, and then try to find the data. So no errors encountered, we are DBA now, and then it will launch the exploit, and it says length 21 byte. Now it will build up the, it will give you the password hashes. So simple. Similarly, it supports the OS code execution. So for OS code execution, you don't need any of this. All you have to do is provide a type 4, which is OS code execution, and then you type a CMD, which you want to execute on the remote box. So c:/nc.exe. Okay, and then if I make a net catalyst null list in here, then this, there you go. So it supports the OS code execution as well. This is again Oracle, so it will run as system privileges, anti-authority system. And this actually cleans itself up. So after you're done with it, it will say, I'll drop the function. I need to do the same for OAP hacker as well, so that not after you leave your pen test, everybody on the client's box has DBA access. That's not really ideal. Okay, just quickly before I get thrown out of the stage, I'll show a small demo of something I presented at DEF CON. And now you remember there was a SQL injection worm which came out earlier this year. And that basically targeted the MS-SQL applications. So what that would do is it would run a massive update query and change your front end. So it will not do anything malicious like execute OS code on your remote database and then hack your DMZ. What it will do is it will basically change the front end of your web application. So when now some other innocent user who connects to your web application, then he now sees this malicious website and not your website, because everything has been changed in the backend database. And now this malicious website will launch some browser-based exploits into this end users. So it will not just target the database, it will target the end users and hacking the client, not so much the server. So so I wrote something similar for Oracle, and this is what I showed at Black Hat. It's the same SQL injection, so you could relate to it. It's a blind SQL injection. Now a little bit about the setup. What I'm using over here is the Metasploit's browser autopone. So I'll do a massive update query in the backend database. So the front end will actually launch a JavaScript, and that JavaScript will then point to the browser autopone. So the browser autopone will then ultimately hack the IE Explorer, Internet Explorer. So I launch a browser autopone here, and then I'll launch the worm somewhere. So it says server started. Now I go to the worm, which is a very trivial worm. It's a command line worm. Normally, worms you would expect to be far more advanced than command line worm. And this worm basically takes a URL. So it then does this massive update statement just over the URL. And then if I refresh my website, then you will see that this website is now changed, and it will now launch a new IE window, which will point to this browser autopone module. I'll refresh this page, and this will pop up a new IE window here, and which triggers the Metasploit autopwn module. And you will see this will have a Meterpreter shell now. There you go, session opened. So now we've got a Meterpreter shell from an IP address, which is the same as the one running IE. So we have not just hacked the server, we have hacked the end users now, depending on what IE version they are using. You can see the IP over here is 103, I think. And I'll do an ipconfig command on this box to show you the IP address of this box. Anyways, that brings us to the end of the talk. Are there any questions?
I think we're running low on time for coffee and stuff like that. So we take questions from the audience and then we go get some coffee. I think, do we have anything from the audience? Is everybody falling asleep?
I think so.
No? Nobody. In that case, thank you very much, Sid. That was a very interesting presentation.
Cheers.
All right.